Hello there, class. This is Gene,
And I'm Josh.
and we're going to talk a little bit about some useful things you can do with computers, mainly algorithms, and how they're used also in everyday life, but a really good way in computer science.
Uh, I guess I should talk a little bit about ways that we can actually use them. But I do want to go over some basics first. I can let's see. Well, I'm going to start Gina off here, typing out a little handwritten thing. We're just trying to add numbers up and then find their square roots, something that can be typed in an algorithm really quickly here. And Gene, if you just want to start doing that for us really quick.
Okay, I think find their squares might be a little easier because finding all their square roots by hand seems like it might take a while. So let's just do a square root.
All right,
Let's
sounds good.
1 through 100 maybe. Sounds kind of easy, you know.
Yeah,
Just one thing at a time, right?
yeah. Okay, so as he's doing that, I'm going to explain some things to you guys. Usually I'm just going to start from the beginning. Here we go. Well, there's a thing called natural language. It's the language that we speak and write in our everyday lives. It's the language we're most familiar with. Um, usually, you can write an algorithm, but it's pretty inefficient because natural language is a little rich for interpretation. Computers don't really know what we're talking about. I mean, if you don't know what the algorithm is supposed to say in the first place, you get really lost and things like that. And it's not very efficient, like I said before.
But a bit of that, I think, often used during pseudocode so that people can kind of see what you're trying to do with your project when it's first in its infancy.
So that being said, usually you want to start an algorithm when you're uh, building your algorithm, when you're designing it. You want to figure out what input operations you're going to want to be using, but also what or what you want your output to be. That's going to be usually like the answer, or what you're kind of trying to figure out. Usually, when you have the input, you want to we have what are called variables. It's simply like a name storage location that you can hold a data value, and you pretty much set the value of that variable to an arithmetic expression. That arithmetic expression can be pretty much anything you want, anything like I have Gene doing over here. He's finding the squares of all the numbers from 1 to 100.
Taking a while.
Yep, taking a while. But we're gonna show you something right after that. When he gets, I'm not gonna force him to do that. I'm not gonna make him take out all that time out of his day. So let's see. Okay, control operations. I'll talk a little bit about those. We have conditional and iterative. Our control operations allow us to alter the normal sequential flow and control of an algorithm. Usually, we do want a sequential algorithm, just a straight line algorithms. You could do your step one, step two, step three, however many steps it really takes to get your point across and to find your answer, to find what you want to do next.
Okay, so we're about halfway through the video, and I'm only at 15, so there's got to be a faster way to do this. How about we write some code real fast?
Let's do it.
Okay, let me just open up this, make a new project. Ooh.
Simply what we're doing here is we're just going to prove to you guys that writing code is a lot faster than writing stuff by hand. And you will soon see why.
Okay, so there we go.
Now, what Gene's going to do here when he's writing this out is he's going to want to put conditional statements in there. They're the question asking operations of an algorithm, the if, then, the else statement, which kind of form the loop. The loop is going to be either with a pretest loop, it's going to be before the beginning of each pass through your body, or after with a post-test loop. And he's going to go with the pretest loop. It's a little easier for people to understand. Pretty basic stuff for most people, for most new computer science majors, be it engineering majors, whatever you are, just, computer geek and want to have some fun.
Okay, let's see if we can get this to open properly. Doing on the fly, sometimes stuff happens.
Yep.
Let's see. Oh, let's just open this up real fast. Let's go with one I already have. Let's see, I think 5 is it. Okay, yeah, so here we go. We already have it all typed up and nice, but basically we have the loop right here. Hopefully you guys recognize that.
I actually, this might look kind of confusing, might look like it's a little bit of stuff, but this is actually a really short algorithm. I actually personally watched him do this over another video that we had. It probably took him a total of a minute to write this out and get the 1 or 2 bugs that he had in there out. So it's pretty nice. Do you want to explain what's going on really quick here, Gene?
Sure. We have the integer that's defined. We bring it in. We're saying I equals 1 just to initialize it. And as long as I is less than 101, it just basically, the thing I was typing out in the notepad, it just kind of says that itself, and looks a lot better than how I did it. And then at the end it just pauses, so we're able to look at it. So let's go ahead and run it real fast. And there we go, 1 to 100.
Beautiful.
Just like that. So what we can do, if we really need it in that notepad file, we can just kind of select them all, and then copy it, and go back to our notepad file, and just kind of right there. There we go.
Boom.
All that time I took, and we're already here. And yeah, pretty simple little algorithm there.
Well, I think we pretty much summed a lot of the stuff up. Is there anything you might want to add?
No, I like the idea of using algorithms to quicken different things that you need to do, because at some points you might need to add up all the numbers in some other way. Maybe you're doing some inventory and you just kind of have a system that's already set up, but this is a lot faster. Definitely does what I was doing manually, just as a computer, and as a tool we should definitely probably use them when we can.
Yeah, pretty much hit it on the nail right there. Well, hope you guys enjoyed it. It was good. We had fun making this little project.
And stay in school.
Yeah, stay in school, kids.